Karthik, the co-founder and chapter lead of NeuroTechX India. So we're so excited to have Firas as our guest speaker for this week's discussion forum. And so to give a brief introduction about NeuroTechX, so NeuroTechX is an international neurotechnology community which has a huge mission of advancing the progress of neurotechnology all over the world. So NeuroTechX India is a very recent initiative which was started in August 2020. But after that, we have had a lot of events and a lot of interest from India and also over the world for the community. It's fast, a very quick growing community. And we have a weekly on Saturday where we get a lot of interesting professionals and experts from all over the world to share their knowledge and experience in the discussion forum. So this week, as I already mentioned, we have Firas from Barcelona. He's the chapter lead of NeuroTechX Barcelona. So we're so excited for the session, and I would request Suhaila to introduce the speaker. Yes.
Hi, everybody. Thank you so much for being here today. I really welcome you all. And firstly, I also welcome Firas, who I have now known for the past year or so, and it's been a pleasure working with him. As Karthik just mentioned, Firas is the chapter lead at NeuroTechX Barcelona. He's a very, very well-known designer, an architect, an artist, a researcher, and also a neurotech enthusiast who currently operates on like several fronts. He's the like editorial board member at this organization which is called UrbanNext, which is an like online platform that like disseminates content with the ethos of expanding architecture to like rethink cities. He's been the creative and tech director and the senior designer at Guallart Architects, designing international urban scale like projects and several of them. Firas, through his various like research endeavors, hopes to define a new normal for design with a neurotech basis in mind, and aims at designing the first architectural brain implant. Over to you, Firas. I'm sure we're going to have a wonderful session, and I would encourage all of you to come and ask all your questions and participate in the like discussion forum. Thank you so much.
Thanks a lot, Sarah. Thanks for you. Thanks for the invitation, and thanks everybody for joining. I'm gonna be presenting throughout the session some of the ideas about neurotechnology and architecture, some of my ideas and my position, some possible future prospects in that field specifically, and then I'm gonna present two projects of mine which just give you a taste of how these two fields can be joined. One is gonna be more in architecture, the other is gonna be more artistic. And then we're going to finish with some conversation and questions. And please, if you have any comments while I'm presenting, just I'd like to have this conversation to be more interactive. So feel free to just drop any comment or question you have as I go in the chat, and then we can be tackling that. So that being said, let me share my screen and start presenting. So just give me a thumbs up if you see my screen.
Yes, Firas, it's visible. Yeah.
Okay, so I have this great introduction, so no need to name my current affiliations at the moment, but I'd like to start with this slide, which is obviously not mine. So this is a slide from one of the reports prepared by the European Commission Research. This is the scientific advisor to the president, that we live currently, or almost there in the age of biology after what has been known the age of engineering and the age of physics. So I want to start with a brief introduction of neurotechnology, and then dive in to what I've been working on. So neurotechnology, in my opinion, has been made possible due to transition in understanding the brain, moving from drawings like this, understanding the physicality of the brain and how it's connected, and then how it is physically. So the brain as a physical entity, moving towards the brain as a chemical entity. So understanding the chemistry of the brain, that was very important. And then lastly, it's what can be named as the electrical brain. So uncovering these phases of understanding the brain is what made neurotechnology what it is. This is a basis for what we rely on and how we work. And then I'm very much interested in the brain activity per se, because neurotechnology can measure that, and then usually in the best of cases, it's a read-write mechanism. So we can not only read from the brain, but we can also write back to the brain. So this read-write mechanism, I think, is one of the most important parts in the work that I'm going to be presenting. So in short, everybody, I mean, we're thinking at the moment how neurotechnology is actually informing a lot of disciplines. So it's entering into marketing, it's entering into design and architecture and all sorts of fields. But then one thing I'd like to point out is that neurotechnology and neuroscience are different. And then neuroscience is itself a discipline that rose by what is called a kind of it's like, I would call it like a selective multidisciplinary kind of mix. So there's a lot of disciplines that were happening, and then selectively and slowly neuroscience can be named what people name neurology outside of the clinic. So this is important because architecture as well is a very interdisciplinary field. And then I think that's a common ground between both. So while neurotechnology informs architecture, I think it's very important for us as designers and architects to think how architecture can challenge neurotechnology as well. This is important for several reasons, in my opinion, but the main reason is from an architectural point of view. I think one thing we do as architects when we design and designers is to ask the question, what is architecture and how we can expand our discipline. And then this has been happening in the history of architecture. If we simplify it a bit, it's been happening due to the emergence of new technologies, which in a lot of times are new mediums in architecture. So we used to design for stones and bricks, then we did drawings for paper, then we do now designs for screens or for virtual reality screens, and so on and so forth. So the medium has been quite important, and then the medium comes as a change in technology. So neurotechnology can definitely inform architectures because it has a scientific basis. It is tied very much to a lot of architectural important points, such as perception, which is the main thing. But now I'm going to explain more things as we move. I want to take a neurotech break at the moment, and then look back to one of the interesting experiences that happened before architects used computers. So if there's any architects in the room, you might notice the guy on the right, who's Peter Eisenman. But then the guy on the left is Chris Yesies, who actually started helping Peter Eisenman, who was an architect, but didn't know that he could use a computer in the first place. So Peter Eisenman was doing what was called operational design. So instead of actually designing a final product, you'd say, okay, get a cube, cut it in 4, scale them randomly, then rotate this, and then you see what happens. So this is called algorithmic or operational design. And then they didn't know how to make this as fast as efficient. So Peter was teaching at the university back then. He asked Chris, who was a computer scientist, to actually try to develop a program in the computer so they can use it to produce these kind of operations and forms. And then this is what later became known as Form Z, which is one of the first 3D modeling software that architects use. While not a lot of architects know that this story has happened, we take it for granted usually that technologies come in and then people in the discipline use them. But rarely do we think that there was actually a need for these software based on disciplinary questions that were asked, and then therefore the software happened. So obviously, a lot of architects at the moment and designers, we use 3D modeling software because it's there. But we tend to forget that one of the most famous and basic 3D modeling software happened only because there was some architects working in expanding and answering disciplinary questions that required new tools, and then that's why these tools happen. So that's what I mean when architecture can challenge your technology in that sense. So I want to show this, which is taken from the homepage of the Brain and Body Imaging Lab at the TU Berlin. And then what's happening here is trying to measure the brain and the body at the same time. And then they're doing this using virtual reality, mobile EEG devices, and much more things that happen on the side. So what happens here is that we see a clear need for neurotechnology to expand while we're thinking about what we can do with it. So, for example, there has been a need for developing EEG devices that could actually measure brain activity while people are moving, as opposed to being static, and that's how mobile EEG happens, right? So there's always a need to expand what's happening and answer new questions, and that's how we can challenge these fields such as neurotechnology in order to get back to architecture and then do what we're thinking about. So now back to architecture and neurotechnology at the same time. So I'd like to make it clear that in architecture and in design in general, we tend to have like this bipolar axis, and then that's where most projects can be situated along the line. So we tend to think about things as being either abstract or phenomenological. So phenomenological is quite clear to a lot of you. So it's how we perceive architecture. That means we think about perception mainly. Abstract is more about the ideation and then the concepts behind this. Somebody is drawing on my screen. Okay, clear all drawings. Okay, so I'd like to introduce some concepts before we go deep into some of the work I want to present today. And then first concept is architectural brain-computer interface. So what is that? In very simplistic terms, architectural brain-computer interface is a brain-computer interface, but this happens when the computer we're interacting with becomes the building itself. So when the space we are occupying or we are interacting with becomes actually the computer itself, because that way the building has access to our brain data and then we have communication with that building. I'm going to show one example here, which is the cerebral hut by Ozil Office, which is, he's an architect. He founded this office, and then they're working on this project where there's this hut, which has this these pentagon panels, and then what happens is that you put on an EEG headset. I think they were using NeuroSky back then, which is a consumer grade, quite basic headset. But then the whole idea, was about so the idea here is this: is that you go in, and then the building is given a microprocessor or a microcomputer. I'm sure people here like work with things like Arduinos and Raspberry Pis and stuff like that. So similar things. And then in that case, what we think about is that now the building has a brain, and then because it has a processing unit, which is communicating with the processing unit of ourselves, which is our brains. And then in that case, we are perceiving the building, but then the building as well is perceiving our brain waves, and then the building can respond based on this. So the building would be responding directly to our brain waves. So in simple terms, the more you're stressed, for example, the color could change, or it can physically change form. So as you saw in the previous slide, there are these tension cables which are changing the form of the structure. So that's the first concept I'd like to bring in. And the second is Neuro-BIM. So BIM in the architectural area space is something quite common, and it is building information modeling. So Neuro-BIM is what we use in a closed loop design system. And then what happens there is that when you model something in 3D, it already has all the information you need so somebody else can read it. So it's quite basic to say that, for example, in BIM, you can measure how much material we have. So if we're building a building out of concrete or steel or wood, it's encoded within the model how much wood we have and how much steel we have and then how much material we have. As you see here in one of the, on the top right, there's a color-coded building, which is showing either the structural analysis of the building. So where are more forces or less forces? Or for example, we can make shadow analysis and sun analysis. So what I'm proposing here is that why doesn't the emotional state of the people in the building become encoded in that building information model? And then what that requires is actually like a lot of data sets that can then machine learning and then software can predict what that space would feel like. And then when I say what the space would feel like, is that what is the data that a brain would, what are the stress or relaxation levels, for example, in a space that we're designing. So in that way, we can have faster and more precise feedback on the mental states or emotional states. And then you're quite familiar, if there's architects in the room again, with this documentary or this phrase, which is, how much does your building weigh, Mr. Foster? Because we've been living in an age where we can actually like quantify the building, and quantified buildings usually where what we can quantify was either material or analysis of some physical stuff. But now that we can quantify mental states, I think it's important to start the conversation where we plug these into conversations when it comes to quantified building. So quantified self and quantified building can be worked out in parallel here. The third concept I'd like to have a conversation about here is Internet of Neurons. While most of us is familiar with the term Internet of Things, things are only the things because we can actually either design them, fabricate them, or quantify them. And then we have communication with these things through either microprocessors or auxiliary hardware that is doing the job. And then that has become possible now that we have access to our brains using either invasive or non-invasive devices. So that was pretty much the introduction I wanted to bring in to start, maybe to spark this conversation. But I'd like to start with something. I usually write, and then I think this is important to start before we even talk about anything else. So I think that the second Copernican turn has not sufficiently changed the design discourse yet. And then it is important, if we want to talk seriously about anything happening within the design discourse in general, or even within neurotechnology, is to have a very to have a speculative but grounded agenda, and do it in a projective entanglement with the present elephants in the room, I call them, which are biocomputation, artificial intelligence, data at scale, and the proposed Internet of Neurons. So this brings us to new concepts that I'd like to introduce, sliding slowly into the perception and architecture kind of realm. You might know these two people. This is Moon and Neil. These are two people who have technology in their bodies, so that's cyborgs. And then one of them, which is Moon, who is a performer. She removed it at the moment. But she had a chip in her leg, which was actually producing vibrations as it was connected to the internet, and then getting data about seismic data. So like she'd get a vibration in her leg every time an earthquake of some magnitude happens. So she introduced a sense to her body where she was feeling earthquakes, but this was only happening because her body, through technology, was linked to the internet. On the other hand, Neil, which is on the right, he has this antenna that you can all see in this image, and then Neil is colorblind. And what happens here is that Neil actually listens to color. So this antenna gets the color value, which the antenna is seeing, and then it transforms this color value into sound frequencies, which go in his skull, and then his brain has been trained to actually decode these sound frequencies into color, and then that's how he can actually listen to color. So this is to say, to establish this concept of the perception and the senses are something that we can play with, we can design, and then therefore we need to think about that, given that most of the way we interact with architecture is usually our senses. And then what I'm really interested in is how to go from interacting with architecture purely using the senses to shortcut this into having technology as the medium between what's out there and our brain and what we perceive. So I want to establish two concepts here. The first one is bidirectional mutation, and then the second one is to talk like very fast about interface theory, because these are important to establish before I explain like before we go deeper into architecture, and then how can that be happening through the project I'm going to show. So bidirectional mutation, as the name suggests, is a change that happens at the same time between two different bodies. So if you, as you see in this map, there's a meandering river here. And then if you think about the river and the water, so the riverbank, which is the actual physical earth form in the ground, and the water. So the most obvious question here would be, what happened first? Is the water changing the physical form of the river, or is the physical form of the river changing how the water is going? But in fact, both things are happening at the same time. So the water would change how the physical thing looks, but then the physicality of that river would suggest how the water would govern how the water is flowing. So we can think here about water being brain activity, and the physical riverbank being the physical brain, because as we know now that brain activity and the physicality of the brain, meaning the connections in the brain, or what is called wiring, are connected. And then this means that the perception and brain activity can actually change physical wiring in the brain, and then that happens vice versa. So here I want to establish another concept, which is the interface theory. That I chose this GIF because I think it explains quite well. So here there's a guy dragging an icon on a screen, which is my computer, throwing it in the recycle bin, and then the computer disappears. So then he calls Linda. And then what happens here is that, in fact, we all know it's a joke, yet we tend a lot of times to think and live and operate within space that way. So what's happening here? What's happening here is that he's dragging an icon. And then what I want to invite you to think about seeing this is that let's think about objects in our world as these icons. And then this screen is our perceptual system. And then what I'm saying here is that there's always a mismatch between what's out there and what we are perceiving, because what we are perceiving is only happening because of an interface called our perceptual system and our senses. Now that I hope I've established these concepts, we can go deeper into what I want to present today, which is my project. One project I did that was 3-4 years back. So I want to start from the end, and this was my actual index list or my bibliography. I chose to do it that way because I think it visually demonstrates how we arrived here in architecture specifically, and then the general flow of how things happen. So if you look at this bibliography, you'd see a very strong connection that happened between things that are in theory of architecture, technology, and philosophy simultaneously, and then how things grow from having to start in philosophy, then going to technology, then going to architecture. But then technology becomes democratized and accessible for non-experts such as myself. Because when I started with this, I had no idea how to do any neurotechnology back then. But then thanks to having what is called consumer grade technologies, and then open source hardware and software, that people can start to play around with these things. So in architecture, working with neurotechnology doesn't have a lot of precedence, but there's a very strong culture within architecture since the 60s mainly, but in general after the Second World War, where architects were collaborating with either artificial intelligence experts or technologists in general to try to generate architecture that has intelligence and response. So the project we see from left to right, the project we see on the left is quite famous. It's by an architect called Cedric Price. And then there's the machine intelligence group at the MIT, who started mainly this movement at scale. And then there's a very interesting, I'd call it pseudo project by Francois Roche, which is the 3-4 screens you see on the right of the screen. So what happens here is that you see, let me draw here. So yeah, you see that person here. She puts her hand on this device, and then what happens in theory is that the device would read emotions, and then after that, they were taking these emotions, then mathematically producing a system that would generate voxels and then they were filling these voxels with these green voxels again. And then this voxel system will become this system over here, where every void and every bulb you see here is actually what you see there. And these are actually residential flats. So these are spaces that people can occupy. So this, what you're seeing here is an actual building. And then the mathematical equations they were drawing was taking into consideration the emotional state of these people, and then putting next to each other people who are more adequately to be neighbors or not, and then so on and so forth. And then all that would be happening through a 3D printing robot, which is what you see on the very right of the screen. So then the robot would print this. So it's kind of trying to automate the whole process of design, conceptualization, forming, form giving, and then fabricating. So when I had all these things happening in mind, I was asking my question, okay, so what should be the next thing in architecture? What is the most important conversation we need to have as architects or as designers in general? And then I thought to myself that there is something growing, which will enable us to do a lot of more things, explore more disciplinary questions, which is neurotechnology, and then where are we from there? So I think if I want to summarize this, the rest of the conversation in one sentence, I would say we can now move from a phase or from a narrative where we have been reiterating this phrase for the last 100 years or more, where we actually design for the user. Every time you talk to any designer, talk to any architect, we're designing for the user. And then what I think is possible and is necessary to do at the moment is actually move from something which is like this to something which is like that. So rather than just designing for the user, I think we have the capacity and the knowledge to actually design the user directly. So when I say designing the user directly, one thing that we can mention here is that now we know that our surrounding, our experiences, and our physical environment can actually shape how we are and how we think, and our emotional states. And then what happens when actually the building knows who we are, right? So this is an image I made with a title like "But Who You Are," because we think that we usually understand the building, but we never think that the building needs to understand us inside the building as well. The other thing I was thinking about when I did this project is a kind of try before you buy kind of idea. So what happens here is that if we can now, I know it's a bit looking into the future, and I'm saying now, but I think because we have the basis, then it makes sense. So what if we can actually simulate how a space would feel before we actually build it? So before you buy a space, or buy means like build or actualize or realize a space, we can actually simulate what is the impact of that physical environment on us. And then this was the other driver of me doing this project. And that was the first sketch device I made in 2016 or 17 when I was thinking about this. So for me, it was quite obvious that buildings only notice us at best as just like a lump, right? So you get close to a door opens, you get far away from the door closes. Or you just pass in, light goes on, you pass out, light goes off. So buildings can at best read humans just as objects. So you don't have to be you to make the door open or close. Like if you put any object, it's just a sensor measuring proximity. So what I was kind of sure about back then is that what we need is actually an interface, which is a hardware and software that I designed, that was actually mediating between the human body and the brain and the building itself. So what I did is this sketch device, which was getting parameters from the space and from the person. So from the person, this was like the version 1, which was like a sketch prototype, and that was like prototype number 2, which was a bit of a development of the first one. I was using, a lot of sensors, but mainly getting EEG data, heart rate data, galvanic skin response, and body temperature from a person, and then getting a lot of other other metrics from the space itself, trying to map it as I'm going to show here. So this is a video I'm going to run. I hope it wouldn't lag too much. So what happens in this video is that I developed this kind of screen where I can see on the top right the brain activity of the person. Under it, what the person walking in the space can see. Then I 3D scan the space so I can internalize the whole process. And then you see in this 3D scan space the position of the person and then the mapping of some emotional states that I was building accordingly. And then I was producing maps like this. But of course, in a 3D model where I'm measuring some changes in mental states and emotional states as the person was moving in that space. So these are just other examples of these, let's call them like mind/space maps. And then after that, I was doing this correlational mapping, which is obviously not very precise at that scale, done by someone who had his like first encounter with neurotechnology. But it was just a proof of concept that this could be a workflow which can lead to something that looks like this, which is my second step. So just to recap what was happening in this project. So what was happening to this project is that I wanted to arrive to a place where we can actually build responsive environments that interact with our brain. To build that, I had to build hardware that was actually the interface mediating between both. And then I developed this hardware I showed, which was my research tool. But the end goal was still to build a space which actually responded based on this data. So I made this box, which was a cube of 3 by 3 meters, 3 by 3 by 3. And then it was generating light and sound based on the person's brainwaves every time the people go in. So what happens here, going back to the concepts I was talking in the beginning, what happens usually in architecture and in any spatial experience is that, I mean, in any experience in general, is that you build what is called perceptual sets. So every time you see something, you build like one layer in these sets. And then my whole idea was like, how can I keep this permanent mutation happening? So you go in, basically what's happening is that you're perceiving the space, then that's changing how you're seeing the space, and then that information would go to the space itself. It would generate new light and sound patterns that goes back, and so on and so on. So it was like a continuous loop where brain and space were interacting using that interface. Yeah, these are just images from what we were seeing, because there was a camera screening to the people who are seeing from the outside. And then that was my take on a device, on one project that I was working, which is an architectural project. I wanted to, because I know that like this is not an architectural audience per se, so I wanted to show another artistic project which has neurotechnology infused in it. And then it's infused in a way to demonstrate that neurotechnology is also getting into art. I think is going to be getting more and more into art. And then I'm going to just show you my take on this. So the idea of this is to introduce these concepts and then play with them to see what we can produce. So we were playing with the idea of gathering biodata and G data. So we were gathering EEG data and at the same time GIS data. And then docking on this concept again, which is the concept of bidirectional mutation to transmit this message. So we were playing between context demonstrated by topographies and then culture demonstrated by brain or brainwaves. That was our workflow. So our workflow goes from first gathering geodata, then simulating it, then gathering biodata, then trying to produce these topographies that are topographies, I mean, infused with brainwaves, but they're produced by an artificial intelligence. So it's the idea of playing with human intelligence, context, artificial intelligence, and see what that interplay can produce. And then after that, we were scanning and running. So yeah, I don't want to take too long here. We were using a GAN, which is Generative Artificial Network. And then what was happening here is that we were teaching this GAN like to produce topographies, and then it would using it would just like starting from random noise, it would generate topographies that would qualify to be considered as real, which means they have the features that look like topographies that we were producing, but then at the same time they were all fake topographies. these are reals and these are fakes, and these are topographies that have encoded in them brain data, which is actually brain data of people who were daydreaming, and then we were trying to produce these dream topographies in a way. This is an artistic work again. That's our, like, I would say, technical workflow, and then here is where neurotechnology comes into play. And then what was happening here is that given this G data that we're having, we were using biodata just of a 4-channel EEG measuring headset, which is OpenBCI back then. And then that was used to actually introduce it as, I mean, I don't want to get too technical here, but there's, introduce it as a place to play with the precision of the topographies that were produced. So I think the aesthetic here was quite relevant. We were picking up the aesthetic of a connectome, which is what you see on the right, which is a mapping of a brain wiring, and then we were generating all these data sets. What you see here is on the left, topographies that the GAN or the AI generated without having introducing these daydream EEG data, and the right is with EEG data. So that's something called, I mean, there's something within the GAN called the latent space, and that's where we were playing with this. Then we were just stacking these topographies and then running a classical agent script that was actually running on the topographies and then trying to reach these topographies from the first one. So by that, creating a connectome of topographies that are generated using a merge of biological data and geological data, all together produced using an artificial intelligence, which is something that we were working with. I'm going to show you this last animation before I close with the last slide. So that was the artwork, which is a video installation that we made. When I say we, it's me and an AI engineer who collaborated with me to produce this work. Yeah. So that's that. I want to close with this slide. While the image on the left shows like an architectural obsession in post-war and modernist tradition with the hand of the architect. So it was always the hand of the architect present in a lot of images, models, and then architects would design cities and then would just put their hand where design is, or design like modular systems like this, and then try to introduce because what you see here is actually so this is a house, right? So they were like introduce houses which are pre-made into these structural grids. And then this obsession with the role of the architect or the architect's hand in a way, I think is going to be, and it's our job to make it shift from something that looks like this to something that looks like that. So what you're seeing on the right is called neural dust, which is a technology quite small, as you see here. That's a human finger, and that's on top. And the aim for me and the biggest challenge is like, how can we produce architecture that can actually sit within this chip? So what I mean by that is that to go back to where we started from in this presentation, that simplistically redrawing the architectural history, I'm going to do it through the change of medium, where we used to do stones and wood, to going to paper, to then going to screens. And then I think eventually screens are going from just screens to virtual reality to augmented reality. And then eventually, I think most of the things are going to be put within direct interaction with the brain using technology. One very obvious, and then one very important example that we see at the moment is that some people don't have eyes, but they can still see. So the perception, as we know, is happening in the brain rather than in the senses. And given that technology can be the mediator or the interface between the brain and what's out there as perception, I think I mean, our role as architects and what is my mission personally is to actually try to develop architecture and think what is architecture that can be there? How can architects design this? And then what are the challenges that this could bring in? I'm going to close with this slide, and then I'll be waiting for your questions and discussions.
Yeah.
Thank
Chris,
you. Yeah.
Is this your last slide?
That's
Hello?
it. That's my last slide.
Great. So first of all, thank you so much, Firas. Like, I was so excited. It was so exciting to see how the future of neuroarchitecture would look like, and such technologies coming into the play of daily lives could really change the way we perceive the world. And so first of all, thank you so much. It was like mind blowing.
Thank you.
Yeah, so I think there'll be a lot of questions. With personally, I have one question. So if you have any questions, kindly unmute your video and audio, and you can ask it directly to Firas.
Sure.
I see Arvind has a question here. Arvind, I think you can unmute yourself and ask the question yourself.
I'm going to stop sharing for that.
Yeah. No, it's fine.
It wasn't that big. I just want to talk about the scales, the micro and nano scales. I just thought of that when you were explaining the arcs and tech. Nothing too specific.
So you're talking about the thing is, we tend to think about scale at the moment, which is a very important topic within design and architecture in general. But like, scale is important always compared to something else. So anything, like when you talk about scale, you always put something to compare with. So you have scale of, let's say, 1 to 10, right? So it's always this part to whole relationship when we talk about scale. And then I don't know if you're talking about the scale of the project or the perception, or the scale of the technology itself.
The technology.
Yeah, so at the moment, like, as far as I'm concerned, I think, I mean, what I know exists is neural dust, and then that's the smallest scale happening. But the idea is less about scale and more about conceptually interacting directly with the brain, because neural dust allows wireless communication between external devices and the brain itself, and then that means we can actually measure things in the brain and then send that data out, and then at the same time we can send electrical pulses using these devices. So what I'm saying is that this same thing can be done using invasive systems, but I'm just showing kind of the state of the art neurotechnology, and then see how we can think towards that. Because in the next 50 years, I mean, I didn't want to show slides that everybody here knows, such as like the Neuralink and what Elon Musk is doing, and then all that thing. So what's happening there is that we are implanting neurotechnology directly in the brain. And then, by the way, let me just say something. Usually technologies, not just neurotechnology, most of technologies usually happen they happen because of very big funding, which usually happens at wars. So if we think about the Second World War, and then what are the technologies and technical developments that happened because of this, it's insane. For one specific reason, is that there was an emergency. That means there was a lot of funding. The best people who were in the field were working under emergency again, and then a lot of scientific research was actually boosted and fueled up there. And then usually what happens is this: is that things start in military research, which is highly funded, then goes to highly funded academic facilities or research, such as like media, like the MIT or Harvard and so on. And then after that, it's taken out of big funding and research labs through either entrepreneurs or people who are kind of technologists. And then these people would just bring what is either called open source, which is one thing, and then you have the consumer grade, which is the other. And then this consumer grade technology plus the open source hardware and software things start like the snowball where everybody has access to these technologies. So that's exactly how it's happening. And then I believe that in 50 years, we're going to be playing with these technologies because at the moment, as architects, someone like me, we're playing with non-invasive neurotechnologies. But I think it's just a matter of time where we would start playing with invasive and go further, because we're in that period of time where invasive technologies are used either for research or for clinical, for saving patients. So for saving people who have lost a limb or people who cannot see, and then things that actually matter, right? Things that saves lives. And then it's just a matter of time where these technologies are going to be in the design industry, the art, and the kind of leisure industry or the entertainment.
I think, yeah. Great. So I have two questions. So first of all, I'd like to get your views on neurotechnology in art, because there are a lot of skepticisms from the side of artists and how technology or AI sort of thing can influence in art, because it's sort of a free thinking or free will sort of thing, which is compared to. So I'd like to get your views on how do you think neurotech is going to influence art?
Yeah. So in general, let me just answer the question by laying down a foundation. I think about intelligence as one thing. So for me, like human intelligence, animal intelligence, whatever intelligence is before anything else, it's intelligence, right? So to categorize, I just want to step one step back, right? So now we're saying that we have intelligence. Okay, there's something very important that I think, can take us a lot of interesting places, which is to understand that intelligence can be designed. So that's number one. So now we're saying that we have intelligence. Usually we break it into artificial and human and natural and whatever. But I would prefer to break it down to two things, which is either mineral or biological. So by mineral intelligence, I mean the intelligence that arises by assembling minerals in a spatial layout, right? So that's mainly a computer chip, which is just a specific spatial assembly of minerals, and that's why I call it mineral intelligence. And then you have the biological intelligence, which is intelligence that arises from biological systems. And then given that distinction, rather than artificial and human, I think we can have a much clearer idea of what these can do in art, in design, and much more. So the way I see these things happening is what people call collaborative intelligence, is that the AI is good doing certain things. Humans are good doing other things. So in art, I think it's quite important to understand that at the end of the day, somebody had wrote code that actually performs intelligent operations. So the role of the artist is the thing at stake, and then the question becomes, does the artist actually paint the painting itself, or writes the code that generates the painting? And these are discussions that are within architecture, within art, but that's the way I understand it.
Got it for us here. So one follow-up to that is one more question. So I'll finish with that. I'm sorry about that. So the second question is, so one thing I've seen a lot of technological advancements in different fields. There's always been an upward progress in a lot of fields. But when I see architecture specifically, mainly in India, we have a lot of architectures here, but still older architectures where the buildings which have been built thousands and thousands of years ago are still being appreciated more than modern architectures. And modern architectures, like buildings, are not. So personally, I've seen very few buildings which are like very beautiful and attractive, which emotionally attracts me towards that architecture. So what is this? What does the future of architecture look like? And
so there's a lot of points here. So the first point is that the axis I showed before. So buildings are appreciated, as far as I'm concerned, for two things. They're either appreciated because they have an abstract quality, so the building has disciplinary relevance or a very strong idea. So that's one reason to appreciate a building. And then, but this is usually the way architects appreciate buildings. But then there's the other kind of appreciation, which is the phenomenological appreciation, which mostly has biological basis. So like why we appreciate a temple or a church or a building or whatever it is how we actually perceive it, and then things in our biological system which makes us appreciate that object or that kind of perception. So nowadays buildings are, I mean, 90% of buildings are not architecture, are just whatever, are just buildings, usually called commercial buildings or whatever. This is not the point. The point is that usually as perceivers or as users, we appreciate buildings for specific things, and they usually have biological basis. Again, that's what I'm saying. And then this biological basis is what people like, is what I'm saying we should actually now study scientifically, and then understand what would the building have in terms of emotional effects, and then design accordingly if we want to have this conversation. So usually what happened in the old days, for example, like churches in Europe, where actually I can think about that as media. So because not a lot of people, I mean, I don't want to like not a lot of people used to be able to read and write, for example. You needed something that actually communicates this spiritual, godly message, whatever it is. So churches were, I mean, the architecture of a church is a kind of media between what you're perceiving and that idea that was governing that time back then. And I think this intention brings in a lot of more work and effort, which is mainly rooted within affecting the experience rather than just selling square meters of buildings, right? And that's why I think this happens.
Got it, Firas, yeah. Yeah, so any more questions? I think,
Yeah, I have one question. So it was really an eye-opening presentation from you, Firas. I can like visualize the future. So just one question from my side would be, when you said instead of the we understanding the building understanding us better, did you mean any like a smarter building, or what did you just mean? Just clarification, that
Yeah.
would be great.
So the word smart is, so like the thing is, you can say smart, but the thing is, for me, the word smart is a word that resonates directly with the whole trend of smart cities. And then I think the word smart is used as like a dumbed down concept, which is intelligent. So I prefer to call them like intelligent spaces rather than smart, because it's a more precise term. But then in parallel as well, what I meant by the buildings knowing us is that now that buildings are having more processing power, so now it's very hard to imagine any advanced building that doesn't have automation within it. So we can see automation in terms of like heating, cooling, lighting, sound insulation, and all these things. These things are already now automated. We see a lot of examples where you have even form is being automated. So the buildings change their ceiling height, you have buildings changing color, and so on and so forth. Well, at the scale of spaces at least. And then what I'm saying is that now that the buildings are having these kind of computers in them, so the buildings are having kind of brains or processing units, why don't we do a link between these processing units and our brains, where the building would actually be responding to that? So I mean, I've given this example a lot of times, but it's very simplistic and reductionist, but just to transmit the idea. So like, who said that if you're in a space, the light should be either on or off? And then who said like you have to go and turn that off when you need? What if the space can understand when are you in an emotional state that requires that much light, and then the light would be gradual. So let's make like a spectrum of light, right? And then the light in the room would change across the spectrum automatically by direct communication between this space and your brain, right? So this is what I'm working on. And then my project was actually what I'm more interested in is actually the unconscious, because if I consciously make a decision, I can just turn on a lamp or off or move something or get in or out. But then what I'm thinking is that when we read brain activity, we're not necessarily reading conscious activity, like conscious decisions or activity. We're reading the unconscious in parallel. And then why don't we use this to communicate with spaces where they actually respond to our unconscious rather than respond to us as just a physical entity which doesn't have any further depth?
Yeah, I think so. So when you were saying that, I was completely relating to Hogwarts, the ceiling, moving of the ceiling, and everything which is being done. So this is it also being done with other physiological signals apart from EEG, like GSR or ECG, HRV?
Yeah, there's like I've seen a lot of prototypes of other things. For example, I mean, like the thing you can think about first for like if you're in a space and then there's air conditioning, the with the galvanic skin response or like some biotechnology like biosignals, you can understand when a person is like like the temperature is comfortable or not, right? And then you would link that to the building's processing unit, which tells you how much temperature should be in that room, and then it will be automatically working that way. And then to do this, that's my whole work, is that we need a device that is actually getting the temperature in the space, getting the data from the person, getting the data from the building, and then trying to work out a circuit which plugs in these three things.
Yeah, it's like super interesting and exciting. Yeah. So any other questions? I think a lot of questions are popping in my mind. So before that,
Hi, I have a quick
Go ahead,
question,
go ahead. Yeah,
if you
Sure.
don't mind.
go ahead, Sai.
Yeah. So, hi, Firas.
Hello.
I was sort of intrigued by the project where you were moving with the headset, the 4-channel headset in the space,
Yep.
and mapping physiological data to the space data, right? So there, how did you 3D scan the space? You used LiDAR or something?
We used very basic photometry. But we were just like taking photos of the space and then assembling them to make this point cloud, which we added texture to, and then became this model you see there. But the idea behind this is that what I wanted to do is to put everything on the same foundation. So because as you know that the space exists out there, and then I have this brain data and all the other parametrics, all the other metrics in the computer. So how would I run an analysis where I have a space which is out there and then data in the computer? So what I said is that I want to bring this space in the computer as well, and then map everything within a 3D space in my computer and then understand how things happen. So that was the reason why I 3D scanned the space.
Okay, cool. And what headsets would you actually suggest for prototyping? Because I used to use NeuroSky before and
Yeah,
BrainLink.
so it usually depends on the budget, I'd say. But what's in, I mean, for me personally, I've used an OpenBCI and I've used an Epoch 14 Plus, which is the one I used for my prototype. And then the problem with some of them is that the data is not open source. And then that means you either need to do a backdoor solution or you need to pay a lot of money to get access to the raw data. But then with OpenBCI, it's quite straightforward, and then it's called OpenBCI, so it's like open source data. So it depends on the precision, the budget you have, and then the exact application. Some of them, I mean, meditation headsets such as the NeuroSky, Muse, and these, I'd say like lower profile in terms of research. I mean, you can do this for basic prototyping, but I think getting like the limit of research prototyping would be either the Epoch, which actually can be used as a mobile EEG, or the OpenBCI boards with sensors.
And what do you do with the sensors that got really old, like outdated?
No, they don't get outdated because at the end of the day, they're just measuring electrical activity. The thing is,
Right.
what do you do with this? Because what they're measuring is literally just electrical activity.
Right.
There's nothing like Hans Berger, which is the guy who actually invented kind of EEG, was using kind of the same sensors. The issue is not the sensing, is the processing of the data. So like you sense this data, you can of course have more precise data, but the whole I mean the whole story is how you process this data and then what you produce from it. This is the difference between sensing and perceiving. So you can sense this data, but like the perception of it with like making meaning out of this data is the actual challenge. So it's not just about the sensors.
Okay,
Anything else,
thanks.
or anybody else? Any other questions? Okay, I just would like to say it's been such a fantastic session to imagine, places being able to, communicate with you back and forth, and being able to actually like design, places which can actually heal people, get better health, like mindfulness and like well-being. And if that seamless communication can be, achieved, nothing like it. I don't know, Karthik, did you want to say anything else? I would just love to thank Firas at this point of time. And I do encourage all of you to, like reach out to him and to also the like NeuroTechX community here in like India and across the world. And if there are any, questions you have or any opportunities which you want to find in terms of like devices, services, jobs, applications, etc., we would be really happy to, support you with that.
I've just posted my Instagram if anybody wants to get in touch as well.
Absolutely.
Yeah. So yeah, I think I just have one update, and I think after that's okay. So you can go ahead. I've posted the social media handles of NTX India, where we'll be updating all the events very regularly. So kindly, if you're interested, kindly follow the social media handles for regular updates. And thank you so much, Firas. It was like an
Thanks a
exciting
lot for the
session.
invitation.
Get in touch with you after this with my further questions and doubts. Yeah, thank you so much. I think so you can go ahead and thank you for this.
Yeah, I just wanted to say thank you. That's all. And it was a really fun conversation. And I'm sure there will be a lot of people reaching out to you, Firas, and I'm sure
More than
they'll
happy.
have questions, and you can always communicate with them one-on-one. And please do look forward to our upcoming talk like next week also, all of you. So we'll have another exciting like session next week as well. Do sign in to find out what that is, and do also join in there. Thank you, guys. Thanks so much,
Sure,
Firas.
thank you.
Yeah.
Thank you
for
very
coming,
much.
and thank you guys for the invitation.
Bye-bye.
Thank you.
Have a good evening there.
Have a good
Bye-bye.
evening. Ciao.
Thank you.